as an intro to the law of sines, I just want to prove the law of sines, and then in the next video I'll go through some examples of how to use it. So let's start off with any triangle ABC. Because it's 3 points, we can draw a circle so that triangle is inscribed in the circle. Then I'm going to draw the diameter of that circle through B. Call that point over here D, so the diameter is DB. Nice property about triangles is that if the hypotenuse of a triangle is the diameter, then we are definitely dealing with a right triangle. So this angle over here is going to be a 90-degree angle. Now what happens as a result is that both angles D and C intercept this same arc. That's going to mean that angle D is the same measure as angle C. Going back to my picture, remember that DB was the diameter of the circle, so its length would be 2r. And in triangle ABC, this side would be side C. And that would mean that the sine of angle D is equal to opposite over hypotenuse, or C over 2r. But C and D have the same measure, so it's the same as the sine of C is equal to C over 2r. Pulling a little bit of algebra here, I can multiply both sides of my equation by 2r and also divide both sides by sine of C. Okay. And that will get a little bit of canceling to happen on each side, and the end result is that 2r is equal to C over the sine of C. So the side to C divided by the sine of angle C. Now if we take the same triangle and inscribe it in the same circle, and this time we draw the diameter to go through point C, then we'll still have a right triangle. And that right angle will still actually be over at the vertex A. Now, with a very similar argument as last time, we see that this arc that D intercepts is the same as the arc that B intercepts. And that means that angle D would have to be congruent to angle B this time. And when we go back to our diagram, remember that DC is the diameter, so now that length is twice the radius, and this side would be side B. Using the right triangle, the sine of D is going to be the opposite over the hypotenuse, so B over 2r. Now, because angle D and angle B are congruent, then we can also say that the sine of B is equal to B over 2r. Next, we whip out a little algebra, multiply both sides by 2r, and divide both sides by the sine of B to get a little canceling to happen. Over here we'll get those to cancel, over here the sine B's will cancel, and what we're left with is that 2r, the diameter, is equal to B over the sine of B, which is very similar to our last result, which said that 2r is equal to C over the sine of C. And really in the exact same way, just drawing the diameter through the third point, we can show that 2r is also equal to A over the sine of A. And that's what gives us the law of sines, that in any triangle ABC, that diameter of the circumscribed circle has the same ratio, A to the sine of A, and that's the same as B over the sine of B, and that's the same as C over the sine of C.